Good morning, everyone. I am Dr.R.Murugesan, Department of Computer Science. So today we are going to discuss about system software. System software is one among the most important part in our digital computers. These system softwares are associated for the use of digital computers. What is Univay system? As you all know, so it is a collection of different hardware devices. What are the devices are connected in a system dependent, all the devices to form a systems. And the next one is software. Software is a collection of program which is used to solve particular task or particular operations. It is a group of instructions or whatever meanings you can use it. So now we have to combine these two. System software. System software is a type of computer program that is designated to run a computer's hardware and application programs. So in the place of system software, mainly we are going to discuss about assembler, compiler, loader, linker or debugger. So it is also called utility softwares. These are the softwares for supporting the operating system. So before we are going to consider this system software, first of all we have to discuss about what are the machine architecture for using this part. Machine architecture consists of 7 types of characteristics. The characteristics are memory, register, data format, instruction set, addressing mode and input output. So there are 7 types of machine architectures are there. The machine architectures are simplified instruction computing architecture, simplified instruction computer with extra equipped architecture, virtual address extension architecture, Pentium Pro architecture, UltraSpark architecture, Power PC architecture, Cray T3E architectures, Pentium Pro and then UltraSpark, Power PC, Power optimization with enhanced RISC. So these is the first two are general architecture, and the next VAX architecture, Pentium Pro architecture, UltraSpark architectures are fall under CISC, and the last two are RISC architecture. So as I already mentioned that CISC architecture stands for Simplified Instructional Computers. This architecture store all data in binary and use the two complement to represent the negative values at the machine levels. And the next architecture SIC, XE, this is just advanced level of your previous one. So this stands for Simplified Instruction Computer with extra equipped. The XE expansion of SIC adds 48-bit floating point and additional memory, addressing modes and extra memories are considered in this place. And then CISC, complex instruction set computing. So in the place of CISC there are 2 types of architectures, VAX and Pentium Pro. VAX, it is an expansion for VAX is Virtual Address Extension, is a series of computer featuring a 32-bit instruction set architecture and virtual memory. And then another one is Pentium Pro architecture. Pentium Pro architecture has a large and complex instruction set having more than 400 different machines are there. So somewhat advanced in our previous one. And then RISC, it consists of 3 architectures. UltraSpark architecture. Spark means scalable processor architecture. It is the processor can easily increasable. It is an extended one. So the family of process. This architecture is suitable for wide range of microcomputers and supercomputer. Another one is Power PC. Power means performance optimization with enhanced RISC personal computers. It is a microprocessor for personal computers. It is very powerful and low cost microprocessor. And then last one from RISC, Cray T3E architecture. It is a microprocessor for supercomputing system. It is an architecture which is very powerful microprocessor. 3E system contains a large number of processing elements. Each processing elements of DEC alpha EV5 RISC microprocessor. So this is a diagram which is mentioned for create T3E architecture. And then move on to the first utility, assembler. Assembler, as you all know, assembler, it is in a language, it is in a low level language or symbolic language. So whatever program which you are going to return, it is converted into machine language. That is the purpose. Convert an assembly language. Assembler is in a software that converts assembly language or low level language or symbolic language is any other language. It takes basic computer commands and converts them into binary code that computer processor can use to perform its basic operation. And then what its directives: start, end, byte, word, reserve byte and reserve word. So each one can have its own properties. Starts, specify name and starting address of the for the program. End, that is end of the source program, indicate. Byte means it is in a hexadecimal constants occupying many bytes as needed to represent the constant. Word, generate one word integer constants. Reserve byte, it is an indicator number of byte for a data. Reserve word, it can indicate the word of a data. So what's its features? Number of features are there. Machine dependent assembler features and machine independent assembler features. So in the place of machine dependent assembler features, instruction formats and addressing modes, with the help of using this assembler in our previous machine architecture, SIC, extended extra equip, and then program relocation. We can be able to relocate the program in some other places. And then machine independent assembler features. It contains literals in the form of numbers, some other guesses instead of using symbols. Symbol defining statements, expression, program blocks, and control section, followed by program linking. And then followed by this case, machine dependent assembler features contains this format. What's its relative addressing, what is its indirect addressing, immediate addressing position, what are the symbols are used, and extended format plus hash symbol and symbols. So these are the symbols are used in a machine dependent assembler features. And then it is in a register to register instruction movements are there. And then now we move on to the next one, program relocation. When assembler generates the object code for the JSUB instruction, it will insert the address of or read record relative to the start of the programs. So these are the methods they can be able to consider for the relocations. And the assembler will also produce a command for the loader instructing it to add the beginning address of the program to the address fields in the JSUB instruction at the load time. And then previously we discussed about dependent. This is an independent. Here we have literals, symbol definitions, defining the symbols. Assembler generates corresponding examples are there. End file, LDA, C, end file A. This is an example for that literals, and then symbol definition, labels and instructions are data areas that values of such labels in the address assigned to the statements. Defining symbols. So this is a symbol, maximum length equal to locations plus LDT, maximum length may mention in this part. Corresponding examples are there. So in this place I have to use .org conditions, that is an origin part, and then how the values can be represented, constants, other symbols, expressions. So, and then the last one, expressions can be classified as an absolute expression or relative expressions. And then program blocks, block of programs. So which is used to rearrange within a single object programming unit. Example, each program block may actually contains several separate segments of the source program. Next one is control sections. So this is also used to loaded and relocated independently of the others. It is used for subroutine or other logical subdivision of the program. Example this part. And then linking, which is used to link one program to the another program related to the control section. What is the control section's information may mention, depends on the instructions it can be able to consider for the program linking. And then move on to the loader. So loader is a part of our operating system that is responsible for loading program and libraries. There are two types of loader, absolute loader and relocating loaders. Absolute loader, it loads a program at a specific memory location specified in the program's object code. Relocating loader, it performs relocating or loading a program for executions. Then another one is machine dependent loader features. There are three features are there: relocation, program linking, algorithm and data structure for a linking loader. Relocation means loader that allows for program relocations are called relocating loader or relative loaders. Text records are the same as before, except that it is a relocation bit associated with each verse of object code. If the relocation bits corresponds to a word of object code is set to 1, the program's starting address is to be added to this word when the program is relocated. A bit value of 0 indicates that no modification is necessary. Program linking, assembled together or assembled independently, each of which consists of a single control sections, a list of items, a list of A, end A, list B, end B. So this is the way they can be able to consider. And then the corresponding algorithm and data structure for linking. And then in this place there are two types of passes are considered, pass 1 and pass 2. So in the place of pass 1, assign address to all external symbols by creating ES table. That is external symbol tables. In pass 2, performs the actual loading, relocation and linking by using ES table. Linking loader has two variables: program order, program load address, control section address. Program load address is the beginning address in memory where the linked program is to be loaded. Control section address contains the starting address assigned to the control sections currently being scanned by the loader. So we move on to the next utility program. Linker is a program. Linker is a program in a system which helps to link object module of a program into a single object file. It performs the process of linking. Linker are also called as link editor. Linking is a process of collecting and maintaining pieces of code and data into a single file. We have to merge two separate files into one for the purpose of executing the system software. Linker also link a particular module into a system library. Types of linking. There are two types of linking: static linking, dynamic linking. It is in a permanent linking. Static, dynamics, it is in a changeable runtime. So for the first one, static linking, it is performed during the compilation of source program. It takes collection of relocatable object file and command line arguments and generate a fully linked object file that can be loaded and run. Dynamic linking. Dynamic linking is performed during the runtime. This linking is accomplished by placing the name of the shareable library into the executable image. There are more chances of errors and failures. It requires less memory space and multiple programs can share a single copy of library. And then compiler. As all you know, compiler, which is an utility program which is used to convert high-level language into machine language. So translator that converts high-level language into machine language. High-level language is written by developer and machine language can be understood by the processor because processor can know only machine code. So that's the purpose of converting one form to the another form with the help of using compiler. Compiler is to show error to the program. If the developer did any mistakes, it can indicate the mistakes. The main purpose of compiler is to change the code written in one language without changing the meaning of the program. Compiler design options. That compiler is a software that convert, as I already mentioned, that convert high-level language to low-level language. High-level language, that is in a source language. Example, from starting onwards, COBOL, Pascal, C, C++, Java, and so on, many languages. And then low-level language, not a low-level language, it is a machine language. Object code or target code or machine code. So there is a meaning for low-level, not for assembly language. The stages of compiler designs. There are two parts to be discussed in this place: lexical analysis, syntax analysis. The first stage of compiler design is lexical analysis, also known as scanning. Scanning means it is overall scans are there, program, what are the codes are there, what are the characters are there, what are the other informations are available. All these things are considered as a token, such as keyword, identifiers and operator. All these things are considered as a token. These tokens are then passed into next stage of the compilation process. And the next stage is analysis, syntax analysis. It is also known as parsing. In this stage, compiler checks the syntax of source code to the corresponding high-level language and ensure that it conforms to the rules of the programming language. The compiler builds a parse tree, which is a hierarchical representation of program structure, and uses it to check syntax error. And then third one is semantic analysis. In this part, checks the meaning of the source code to ensure that it makes sense. The compiler performs type checking, which ensures that the variables are used currently and that operations are performed on compatible data type. And then corresponding check the other semantic error. Code generations. The fourth stage is compiler design is code generation. In this stage, the compiler translates parse tree into machine code that can be executed by the computer. The code generated by the compiler must be efficient and optimized for the target platform. Optimization. The final stage of compiler design is optimization. In this stage, the compiler analyzes the generated code and makes optimization to improve its performance. Optimization, as you know, optimization we have to bring into a correct, exact method. The compiler may perform optimization such as constant folding, looping, unrolling, and functional linking, and a debugger. What is the purpose of bug? Bug is some errors are there in your source program that could be corrected using this part, debugger. Debugger is a software tool that can help the software development process by identifying coding errors at various stages of the operating systems or application development. Some debugger will analyze a test run to see what lines of code were not executed. Debugger is a tool that allows you to examine the state of the running program. Debugging is the process of locating and removing bugs or errors in a program. Debugging is a mathematical process, methodological process of locating and eliminating bugs or defects in a computer programs. There are two types of debugger: static debugger, dynamic debugger. A static debugger does not rely on any specific software. The debugging can be completed by the users. Dynamic debugger can be either software or hardware. And we move on to the next one: functions and capabilities for the debugging. Debugging systems should be provide functions such as tracing and traceback. Traceback can show the path by which the current statements in the program was reached. It can also show which statements have modified a given variable or parameters. The statements are displayed rather than hexadecimal displacement. And then interactive debugging systems. Debugging functions and capabilities, debugging process, program display capabilities, relationship with other parts of the systems, and then user interface criteria. User, what is the devices are used to make a connect between the user and the systems. That is the main part in this part. Debugging systems should be simple in its organization in the language closely reflect common user tasks. The user interaction should make use of full screen display and windowing systems as much as possible. With full screen editor, the user has far less information to enter and remember. So thank you very much for listening system software fundamentals. It is in a cover overall idea behind these things. Thank you very much.